Hey, everyone here at the House Now 3D podcast slash video series. We are on series 7. Sean, hey, thanks for being with us. My co-host Sean, always just so eager to talk here. Sometimes I forget about my co-host, but hey, thanks, man. How you doing?
Hey, everybody. Thanks so much. Episode 7. Let's do this. What are we talking about today, Johnny?
We're discussing the types of concrete and additives for 3D printing. We know the that has a huge effect on the process, on the build, on the machine. It's related to the machine. There's a lot of things that really important topic touches and factors in. So, Sean, what are some of the considerations and challenges that you've seen on the types of concrete and additives?
Wow. I guess it would come down to, I guess you'd say it's rheology, just how things flow and mix and settle and how do they structurally combine. There's a lot of great companies out there. Some of them you can get their material, from them. They're doing the science, they've done the testing, the compressions, the strengths, the core samples. And other people, say you want to make your own formula, if it's Portland cement, the different types of sand, wash sand. I didn't know till I looked into this that you don't want to use like beach sand because beach sand is in like small little round ping pong shapes. So when you try to put that together and actually make a concrete, it doesn't work. So you can use like silica sand, volcanic ash, there's fly ash, there's quartz, there's additives. Up and down the spectrum from,
Yeah.
I'll just take a look at some of my notes here. It's absolutely insane. There's thousands and thousands.
And I'll just insert real quick in here, Sean, that from a kind of material science perspective, we know that this to be true in life, how it's easy to not be able to hold on to a ball versus like the sharp cornered rock or a square box. Really easy to grab onto that, especially if there's like liquid or anything around it. So like that smooth sand, the spherical sand, obviously it doesn't bind as well, but you have like the silicas and other things like that. It's got a lot of sharp, ragged, jagged, sharp edges, and it really bonds for incredibly high strength. So just a kind of a side point on, just like something as fundamental as the sand in the aggregate.
Yeah, and I didn't know this either. That like if you're in a desert, like, oh, we've got all this great sand. It's a lot of times it's too fine to actually bind the way that you'd want it into a cementous material. But there's so many people out there in the material science world who are doing testing, and like every week we see somebody coming out with something new, and they're just beating it up against the wall literally and hitting with sledgehammers to be like, hey, does this work, does it not work? Self-healing concrete I think is possible in time. It's not there yet with nanoparticles, and some people were saying from years ago in articles that some of the Roman Colosseums were self-healing. I have no way to prove that or not, but they're actually doing
Yes.
material sciences of like, why did these things stand up so strong for so long? Was it the volcanic ash that was in it? Was it the lime that was in it? Was it actually heated up before it was poured in? So there's conflicting reports on it, but I find it very interesting to be learning about a material science that's thousands of years old. And a lot of the structures are still standing, up against all the elements. And
Right.
we weren't using rebar at that time. So there's something we can all learn from that. So the material science, I think is extremely interesting. And in time, like I said, there's going to be less and less Portland cement, or they're going to be finding ways to have zero carbon emission Portland cement, which is a very exciting field.
Absolutely, man. And then well, then of course, yeah, of course, within that, obviously, the less cement you use, then that's really the hard part to make. That is, you can reduce that content of cement, and you end up with an equally or a close, strong enough type of aggregate, that sets up. Then that's where you really kind of direction where you're going with this. Anyway, so that's just kind of a final thought there. So let's go into another topic here. So how about the selection and appropriate concrete for 3D printing projects here? So I guess like, do I want to use grout? We know like all this stuff is like, if you get it wet enough, you can pump it, but there's grout and there's like thicker aggregate and stuff with, more sand and less sand. What have you seen there?
Mixes, formulations can be difficult. Like I said, there's some great people out there where you can get it dropped off in super sacks of say 3,500 pounds. And, you've got to just work out the material and your weather conditions, and it should flow until you get it in your state. And sometimes you want a little bit of a messier mix on the bottom. And then just as you go around, it gets better and gets better. There's so many different mixes
And a
out
lot of
there.
and there's a lot of academic work around the
Mhm.
world in this because lends itself. There's a lot of obviously civil engineering programs and material science programs that have teams of engineers and PhD scientists and all these things focus on this problem, right? The different kinds, like you said, of the mixes and whatnot. So yes, we have industry, yes, we have people in the field trying stuff, but also there's a tremendous amount of research from the stuff that we've seen. We visited Oak Ridge National Labs a couple months ago, Sean, you and I, and a few other folks, and we just saw some tremendous science happening there. And then, of course, there's some of the people there just focusing on the mixes and the ratios and proportions and the kinds of cement. So that was really exciting as well.
Yeah, I was blown away when we actually went down to Oak Ridge National Labs. If you guys don't know, that's one of the largest funded research facilities in the United States and around the world. But we got an invite to come down there with some of our team members, and I felt like I was walking into like an Iron Man magic vault. They were doing very large scale 3D printing. The array of materials that they were using, testing, compiling, and actually making new materials. It's above and beyond. It's one of the most cutting edge facilities in 3D printing, especially for large additive manufacturing with robots. And like I said, they've got teams who do just geopolymers. They've got teams that just do cementous material. And all these people are very, very high end. Glad to call some of these people my friends that are doing amazing work. And we hope to collaborate with them as we try to push the boundaries of, new materials, because a lot of that comes from the Department of Energy, a lot of their funding. And, we want to find a way to use less energy, to heat our houses, to cool our houses. What about,
To make our houses, right, Sean? To make all the total energy input of a house that exists anywhere. How can we reduce that energy consumption, that energy, and that overall energy bill? Is an excellent way of thinking about that as well.
And they were speaking about, there's possibilities of self-generating powerhouses based on like the house is going to move so much, or your vibrational frequency of the floors or opening the doors. Like, how in time can you use that, capture that energy and reuse it in the house? And you're like, wow, that sounds absolutely crazy, but it's really not. Technology grows exponentially, and I'm just very excited to keep learning, because what we're doing today and what we're going to be doing in 3, 5, or 10 years in the manufacturing of houses, and 3D printing, construction, I think is going to be day and night.
That's incredible, man. To take us out here on this segment, Sean, what have you seen that's kind of interesting, and what can it do? Is kind of, we look at just the additives, and then maybe even some modifiers, if you would. Anyone that's poured concrete before for flat work or walls, you
Mhm.
can add like calcium chloride to, basically if it's in cold weather, you can add something like calcium chloride to heat it up a bit. You can add plasticizers, and there's like a lot of different additives. Do you see kind of this the world just getting like one kind of like universal mix and then just adding a bunch of stuff? Or what kind of enhanced performance do you see when you could basically like use the local stuff and then just ship in some high-end chemicals, some modifiers to make it work? What do you think? Where do you think that's going to go? Like, special mix or regular mix around the world with modifiers and additives?
I think each unique is built. There's some companies out there where you can use 99% of the mix locally sourced, and you get
Yes.
1% of their, say, magic mix or magic ink.
Yeah.
Uh, I've not tested that material, but I think it's a fantastic way to, make it accessible around the world. Other people are talking about, hey, what you have to build and your mix are all going to work together in unison. Are you going to need different types of fibers in it? Or are you going to need something to make it extra strong, depending how many floors you're going up? What are you guys supporting, with the structure? And I think every house is unique. There's some people that say, look, we just want to use our material, which is totally understandable. Some materials work very well in some machines and not other machines. There's manufacturers out there where you have to use their mix or you can void the warranty, which is totally understandable, because they spent the time, they spent the money to formulate these things. So
Right.
you don't have to do the hard work. And there's other people who want to use, earthen material that's earth, mud, straw, dirt, and say we don't want, any type. So there's an interesting conversation to be had with, different manufacturers of machines and materials. And I think in time there's going to be more standards set up for locations all over the world and best practices. And to come together and share information, I think is very beneficial, instead of just having one team saying, well, this is what we do and we're right, and we do this and we're right. So hopefully in time there's going to be more acceptance, understanding, and cross working together in the industry.
That's awesome, man. Well, folks, that is a wrap for this series. Again, this is series 7. And just to kind of recap, we talked about from an overview of different concrete mixes and formulations, selection of appropriate concrete for 3D printing projects, and then additives and modifiers for kind of enhanced performance or even local sourcing and availability. So until next time, thank you for watching. And of course, leave us a comment, follow us, of course, on social media. And we just love to keep providing great content and information like this and just having more of these conversations. Until next time, later.
Peace.